Hi everyone, welcome back to the Sky Appliance YouTube channel. My name is Mehdi and today I'm working on an LG front load washing machine displaying the LE error code. This is a common issue with LG front load washers and even some top load models, so I'll walk you through diagnosing and fixing it. Let's start a cycle and see how the machine works. As you can see, it tries to turn the drum, but it makes some jerky movements. It also makes a grinding noise like this. And eventually shows the LE error code. By the way, you might think the grinding noise is coming from the bearing. However, if you turn the drum by hand, there's no grinding noise, which indicates that the bearing is fine. What does the LE error code mean? Generally, it indicates a motor-related issue, often due to sensor issues, wiring problems, or overloading. In most cases, the LE code is triggered by something causing the motor to lock up or stop rotating properly. Let's go through the steps to diagnose and fix this issue. The first step is to reset the washer. LG machines sometimes display an LE code if there is a temporary glitch. Unplug the machine for about 10 minutes to allow it to reset. After plugging it back in, try running a short cycle to see if the error returns. In our case, the client already tried this and it didn't work. Overloading can also cause the LE error. When the machine is overloaded, the motor can't spin freely, which can trigger the LE error. Check if your load is too large. If so, remove some items and try again. In our case, the machine shows the LE error code even when it's completely empty, so that's not the issue. The next step is to check if the drum can move freely. Sometimes an LE error is caused by a physical obstruction, like a small item that slipped between the drum and top. Open the door and gently rotate the drum by hand. It should move smoothly without resistance or unusual sounds. If it feels stuck or hard to move, inspect inside the drum to see if anything is wedged there, or check around the seal for foreign objects like coins, buttons, or small garments. In this case, I can turn the drum freely and smoothly by hand. If you feel any resistance, try unplugging the washer, wait a few minutes, and then try again. For the remaining steps, we'll need to pull the machine out to access the back. Be sure to unplug your washing machine or turn off the circuit breaker for safety. It's also a good idea to turn off the water supply lines as well. The rear panel is secured with 4 screws. I'll remove them and then push the panel up to take it off. The next step is to check the wiring harnesses connected to the motor and hall sensor. Carefully examine them for signs of burn marks, damage, or loose connections. Sometimes, if the load is too large or the hall sensor is faulty, the motor draws too much current, which can burn a wire. In that case, you might see a burn mark on this white tape. In our case, the wiring harnesses look fine. Next, inspect the rotor. If the rotor is jammed or damaged, it can prevent the motor from spinning and cause the LE error. Look for any visible damage. The rotor is secured with a bolt which you can remove using an 11/16 or 17mm socket. Once the bolt is out, pull the rotor off and check its magnets to ensure they're not broken. The stator is very reliable and lasts very long. It's secured to the tub with 6 bolts, and there are also a few screws holding the wires in place. Before removing the last bolt, I'll support the stator with my other hand. Now, let's test the stator windings. This is a brushless motor and it has 3 similar windings. You need to use a multimeter to check the resistance of the windings. You should see identical ohm readings between each pair of terminals. By the way, the ohm reading might be slightly higher or lower than 12 ohms depending on the model. Now it's time to check the Hall sensor. The Hall sensor, also known as the rotor position sensor, is a key component that monitors the rotor's position. A faulty Hall sensor triggers the LE code. There are a few steps to check the sensor properly. If you don't have a multimeter, you can go ahead and replace it since it's a very common issue, but I'll show you how to test it correctly. Let's remove the sensor. The first step is the ohm test. The resistance between pin 5 and pin 1 as well as pin 5 and pin 2 should be roughly 10 kiloohms. If either test shows an open circuit, the Hall sensor is defective and must be replaced. The resistance between pin 5 and pin 2 is showing OL, so the sensor is defective and must be replaced. The next step is the volt pulsing test. I'll use a new sensor to demonstrate. First, I'll connect pins 5 and 4 to 10 volts DC. Then I'll check the voltage pulsing between pin 1 and pin 4 and between pin 2 and pin 4. I'll move a magnet in front of the legs to observe the pulses. Here's an alternative method for checking voltage pulsing. Here's how to test the control board if the first 7 steps passed all tests. Let's get back to the washing machine and replace the sensor. This is the part number that fits almost every model. There are 5 small locking tabs that secure the sensor. You'll hear a clicking sound when the sensor is seated properly. Make sure all 5 clips are securely locked. Hold the stator firmly against the tub and line the holes for the bolts. The sensor should be located at approximately the 8 o'clock position. Now it's time to reinstall the rotor. Be careful as the magnetic force can pinch your fingers between the rotor and the tub. You can apply a bit of red or blue thread locker to the rotor bolt. If you don't have a helper to hold the drum, you can use a screwdriver to jam the rotor in place while tightening the bolt. Now I'll plug in the machine and run a quick wash and spin cycle to make sure everything is working normally. If you found this video helpful, make sure to give it a thumbs up and subscribe to the channel for more appliance repair tips. Thanks for watching, and I'll see you in the next one.